Greetings, salutations, all those nice things. Welcome to our first lesson of Topic 3, Trigonometry. It's the first of, I think, 4 trigonometry units we're going to have this year, so brace yourselves, buckle in, and let's get started. In this first little bit, we're going to talk about this new type of way to measure angles. And by new type of way, I mean it's been around for a while, but it's new to us. And these things called radians. Woo! Radians. And it's kind of a useful and interesting measure. I mean, we're used to degrees, and we know that a full circle has 360 degrees. So what are these radians things? We're told right here that 180 degrees is equal to pi radians. I would want to know why. If we want to look at that, here's how it goes. A full circle is 360 degrees. And a circumference of that whole circle is 2 pi times the radius. Or we could say that's 2 pi radiuses. That's radii. Let's be real. So, if 360 degrees is the same thing as 2 pi radii, well then, dividing by 2 means that 180 degrees is equal to pi radii. And that's where it comes from. It's that relationship between 2 pi r being the full circumference, and going around that full circumference means that you're rotating 360 degrees. So for that reason, we have this business. And we can convert between the two. Now, if you have something in degrees, it is very necessary that you put that degree symbol there. If there is no unit indicated, it's assumed to be radians. Just worth noting. So conversion-wise, if 180 degrees is the same as pi radians, then there's our conversion rate. I mean, pi over 180 degrees is equal to 1 because pi radians is equal to 180 degrees. So that's how we do that. And then all we have to do is simplify that particular fraction that we get. So let's try some. Here's some examples. We're going to convert 120 degrees to radians. Well, 120 degrees is the same as 120 degrees times pi over 180 degrees. And we could say that's 120 degrees times pi over 180 degrees. At that point, we just need to simplify this business of 120 over 180. Word on the street is that that's 2 over 3. So 120 degrees is equal to 2 pi over 3. That's 2 pi over 3 radians, but we don't need to say that at all. So just 2 pi over 3 will be sufficient. I triple dare you to try the other examples on this page. I pentuple dare you. See what you can do. These next 2 convert to radians, and then these 3 make you go from radians to degrees. So give them a try, give them a stab, give them a whirl, give them a shot, and see if your answers are the same as my answers. La 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 la. How do I do this again? So multiplying by that conversion rate. And I have no idea what that is. What are they both divisible by 5? I guess they're also divisible by 15. Whatever, I'll get there in the end. How many times does 5 go into 180? 36? Is that accurate? Does 5 actually go into 180 that many times? 180 divided by 5. Brilliant. And I just need to reduce that further. 5 goes by 3. Boom. So 75 degrees is equal to 5 pi over 12. 270, so we're going same here. Same process. And 270 over 180 is 3 over 2. Sorry if my pi doesn't look like a pi. I can make better pi. Okay, maybe I can't. There we go. So that's converting to radians. These other ones we can convert to degrees. Now the first two, we're going to go non-calculator. And then this last one where it says the nearest degree, that one we're going to have to use a calculator for, because there's no real other way. It's going to be approximate. So, in we go. If we're going to convert pi over 6 to degrees, we're going to involve the conversion rate again, but there's no sense in multiplying by pi over 180. That's not really going to do as much. It'd be nice to get them pi's out of there. So we need to introduce degrees. So we'll have 180 degrees over pi. Nice. In doing that, we'll do some simplification. We have 180 degrees times pi over 6 times pi. What will that do for us? Well, 180 degrees divided by 6 is just 30 degrees, and the pi's eliminate. So pi over 6 is equal to 30 degrees. And that's one worth memorizing if we're really going to be honest, because 30 degrees, you might remember, is one of our nice special angles. Any poops, try the others, see what happens. Pause if you need to. I am moving on. 7 pi over 3 is 7 pi over 3 times 180 over pi. Them pi's cancel. So really I just have 7 times 60 degrees because of that business. What you feel? This is 420 degrees. And this last one, operating the same way. We know it's in radians already because there's no units indicated, so it's assumed to be such. And once again, we're multiplying by 180 degrees over pi. And at this point, I'm going to calculator. I'm really just going to go 5.82 times 180 divided by pi, because we're approximating. There's no other way to get around this one. So 5.82 times 180 divided by pi. According to my calculating device, that's like 333.4614367661391. Maybe there's some other stuff after there. But we're asked to do this to the nearest degree. So this is just 333 degrees. Don't want to get that rounding error. That would just be embarrassing. So that's our conversions bit. We're also going to talk today about coterminal angles. Coterminal angles essentially point in the same direction or open the same net amount. Like if I spin 180 degrees and I spin 540 degrees, I'm still going to face the same direction. So when two angles are coterminal, that's like if you draw them, they have the same terminal arms. They end up in the same spot. So if I'm facing some direction, in purple, I'm looking that way, and I do a full 360, well, I'm still going to be facing that way. And if I do another 360, I'm still going to be facing that way. If I reverse 360, I'm still facing the same way. If I reverse another 360, I'm still facing the same way. And no matter how many times we add or subtract 360 degrees, I'm still facing the same way. So if we add any multiple of 360 degrees or any multiple of 2 pi to an angle, which is a whole revolution, we have something that is coterminal. So we can say that 80 is coterminal with 440 because 80 plus 360 gives us 440. And if we take that, if we take 440 and add 360 degrees, boom, we have 800 degrees. Or if we take 80 degrees minus 360 degrees, boom, we're at 280. If we take something like 2 pi over 3 and we add 2 pi, noting, of course, that that's like adding 6 pi over 3, then we'll get 8 pi. And if we add another 2 pi, so another 6 pi over 3, then we're at 14 pi over 3. Or if we take 2 pi over 3 and we subtract 2 pi, which is the same as 2 pi over 3 minus 6 pi over 3 for that common denominator, then we'll get over here. So we can always add or subtract 360 degrees or 2 pi to get something coterminal. Give it a try right from the get-go. See if you can determine two angles coterminal with each one of these. Oh, and this one is a slightly different question. But give it a go, give it a stab, give it a shot, give it a whirl. In I go. So 210 degrees, I might add 360 degrees, and that'll give me a value of something. According to my skills, it's 570. If I want, I can add another 360 degrees to that, and I can say that 930 is coterminal. If I want, I could take one of these angles, I could subtract 360 degrees. And if I wanted to do that, I could get another coterminal angle. So it says 2, I gave you 3. These are all coterminal with 210 degrees. 40 degrees. Oops. Yeah, never forget my units here. Plus 360 degrees is that many. Or if I take that, then I get this many. Or I could take 40 degrees and subtract 360 degrees, which means I'm at negative 320 degrees. If I wanted to provide a fourth option, I could take 320 degrees and subtract another 360 degrees. So where am I at? 680 in the negative direction. So those are all coterminal. And there are infinitely many options with any one of those. Because I could add like 100 times 360, or I could add 360 degrees 84 times. However many I want to go with. Determine two angles coterminal with 3 pi over 4. So 360 degrees is the same as 2 pi. Lock that info in. So I could add 2 pi to this. You do not need to show, oopsie daisy, you do not need to show that you're making this have a common denominator, but you can do it for your own sake if you want. So 2 pi is the same as 8 pi over 4. Adding all that, we have 11 pi over 4. So 3 pi over 4 is coterminal with 11 pi over 4. If I want, I could add another 2 pi. Again, you do not have to show your conversion to a common denominator. You just need to make sure you can get an equivalent angle, or coterminal angle, I should say. And just as we added in the above ones, we can just as well subtract. And I can say we have 3 pi over 4 minus 8 pi over 4. So subtracting 2 pi and give us negative 5 pi over 4. All of these, again, are coterminal with 3 pi over 4. Last one of these is provide an angle that is coterminal with this, given that it's in this specific range. So this value here is not, because 31 over 6 is a little over 5. So 5 and some change. So we have 5-ish pi, which is way more than 2 pi. So we need to whittle this down a bit. So let's give that a try. Obviously it's too big. Let's try subtracting something. 31 pi over 6. We're going to get rid of 2 pi, which is the same as subtracting 12 pi over 6, which gives us something like 19 pi over 6. Is this done? No, it's not, because 19 over 6 is like 3 and some change. Whereas we need to get to just 2 pi's, not 3 pi's. So we're still too high. Too high. So sad. So we'll subtract another 2 pi. And that gets us 7 pi over 6. And that is within our range. It's more than 0, hooray. And it's less than 2 pi, where 2 pi is 12 pi over 6. So this thing's all good to go. This one we can say is done. And our final thought with coterminal angles is the general form of a coterminal angle. So I said there are infinitely many options earlier that you could add 360 degrees once or twice. I think I used the word 84. So you could add 84 times or 100 times, as many integer times as you want. And that's what this says, is that you can take your angle and add 360 however many times as you want, as long as that number is an integer. And similarly in radians, well, you have your angle, you can add 2 pi, or 1 whole revolution, as many times as you want, as long as the number of times is an integer. Blah, blah. So, in proceeding with that, we want the general form of angles coterminal with 200 degrees. Well, that's in degrees. We're going to use this form. So 200 degrees plus 360 degrees times k. And that is where k is an integer. So we're saying we can plug in any integer value here, and it will be coterminal. K could be 7. So if we add 367 times, we'll still have something coterminal. If we do it negative 17 times, then we'll still have something coterminal, because it's still some multiple of 360 that's being added. Yeah, that one's done. Quick, try this next one. Try just only 2 more, right? Yeah, that's about right. Try this next one. Pause if you need to. I'm going ahead. We're in radians. So I'm going to add the radian form. We're going to add 2 pi. And we're going to do that k times, where k is some integer. And finally, this last one. Oh, is this degrees or radians? Degrees? Radians? I have no idea. Just kidding. Units aren't mentioned. There's no degree symbol here. This must be in radians. So just as the one above, we're going to say we're going to add 2 pi k, where k is some integer. So that's kind of all the lesson-y bits. Worth noting is that a full revolution, which was mentioned earlier, is going around the circle 1 whole time. maybe in the other direction, technically. So that's equal to 360 degrees, or it's equal to 2 pi. So if you need a number of revolutions, you can always divide by 2 pi or divide by 360 degrees to determine how many times that happened. Like, you spun through 1080 degrees, how many times did you spin around? What is that equal to? So you'd be dividing by 360. But revolutions are also moderately interesting. Dayite. Any poops. There is some practice work for you, so you can play with this textbook work. I would recommend trying all those questions. Give them a shot. And if you have any questions as you do so, please do let me know. Contact via Teams or in class, however things work out for it to be. That is all. Goodbye. The end.